Hi everyone, welcome to your YouTube stream, and about 15 minutes of past paper practice. And today we are going to be focusing on differential calculus, as we have been for the last week or so. And I'm just going to check my stream health and see. Okay, so it says the stream health is excellent. Just going to test this out. Hello, grade 12s. All right, and then we're going to go for it. Okay, so let's see what we have here. They say given f of x is equal to 3x cubed, and what I'm going to do is I'm going to make this slightly bigger. There we go. Just so you can see it properly. Actually, let's see if we can make it even bigger. There we go. All right. So, what am I given here? I have a cubic function here. I have a cubic. I know that. I can see that from the form. We know that the equation of a cubic is in the form, well, let's just refresh your memory here, in the form ax cubed plus bx squared plus cx plus d. All right, now in this case, you'll notice that I have an a coefficient of 3, and then the rest of the coefficients b, c, and d are all 0. In that case, I know that my x-intercept or my y-intercept will be 0 and my x-intercept will be 0. They start by saying solve for f of x equal to f dashed of x. So let's go through that first, and let's do that in black because we're answering the question. I like to break it down into steps. So my first step, of course, is I'm going to say, okay, what is f dashed of x? Well, I know f dashed of x, if I use my differentiation rules, it's going to be 9x squared. Okay, and of course, then I'm going to solve, and I'm going to say, in this case, where is 3x cubed equal to 9x squared? Now, whenever you have something like this, what I would recommend, and this is going to be your step 2, of course, the step 3, what I would recommend is take all of the variables over to one side, or take everything over to one side. And if I do that, I then get 3x cubed minus 9x squared is equal to 0. And of course, I can solve this in step 4. If I pull out a highest common factor, my highest common factor in this case is 3x squared. And what am I left with? Well, I'm left with x minus 3 is equal to 0. And from there, of course, I then get that x can be equal to 0, or x can be equal to 3. Okay, so that's my answer in this case. And do I have the model solution here? No, I do not, but I don't need it. Okay, but what you're going to notice is this is the answer for question 9.1. Right, now what does it mean? That means this is where the graph of the cubic and its derivative are intersecting. So they intersect at 0 and 3. All right, so that's the first question, done and dusted. We know x is equal to 0, x is equal to 3. This is how you would do it. And let's just see if we can go for the next part of the question. Okay, keeping that in mind. All right, then they say the graphs of f dashed, and f double dash all pass through the point 0, 0. Okay, now it might be good to actualize or visualize this. Okay, if I drew this graph, and let's say I do the original graph in 0, I know it's going to be an increasing function. So what I know is that it's going to be going like this and going up like this. And that, of course, is going to be my cubic, 3x cubed, right? And then they say f dashed, which we know is 9x squared, because it's going to pass through this point. So it's going to pass like this, and go there, and then go like this. Now we also know that this graph, along with its cubic, meets at 3, and they meet at 0. Okay, and then they say f double dash passes through the point 0, 0. And then they say in 9.2.1, for which graphs or which of the graphs will 0, 0 be a stationary point? Now, we need to understand what a stationary point is. Okay, so remember, a stationary point is a turning point. It's used interchangeably. All right, and so of course we can see, right, a stationary point. If we found, remember, we need to find the derivative. We know that the derivative, and this is for 9.2.1, we know that the derivative f dashed of x is equal to 9x squared. And of course, to find the turning point, I then equate that to 0. Now, if I solve for this, I then get x is equal to 0. So I know that there is a turning point of my original graph. So I know f dash or f of x is definitely a stationary point or has a stationary point. And now if I take the second derivative, right, that will give me 18x. And if I equate that to 0, right, I then get x is equal to 0. And then I know that f dashed of x has a stationary point there because that's a turning point there of the green graph. Now, right, it all passes through the points, but remember in this case, if I find the third derivative, I just get 0. Oh, sorry, I just get 18, I get a constant, which means that that is not a stationary point. So that's my answer for 9.2.1. Okay, that's how I know. Let's remove this and let's go to the next part. So explain the difference, if any, if the stationary points referred to in 9.2.1. Now, what is the difference between the stationary point, right? Now remember, with the second derivative, right, I know the second derivative is equal to 18x. Now, if I equate that to 0, right, what do I get? I then get x is equal to 0 again, right? Now, what does that tell me? That tells me that there's a point of inflection here as well, okay? So in that case, I know that for f of x, I know that I have a turning point, okay? And I also know that I have a point of inflection. And then for f dashed of x, I just know that I have a turning point, and that is the difference in this case, okay? All right, then they say determine the vertical distance between the graphs of f dash of x and f double dash of x at x is equal to 1. So in 9.3, right, we know f dash of x is equal to 9x squared. So we then plug in 1, right? And so if I plug in 1, I then get 9. So I have the point 1 and 9. And for f double dashed of x, I have 18x, okay? And if I plug in the point 1, I then get 18, right? So then I have the point 1 and 18. Now, if they want the vertical height, okay, or the vertical distance, remember distance is always positive. So the distance, of course, would be between 9 and 18, and then your distance is going to be 9 units. Okay, that's your answer for 9.3. Nothing too difficult there. And then the last one, right, let's look at 9.4. Okay, so for 9.4, they say for which values of x is f of x minus f dashed of x less than 0. So remember, same story. What you're going to do is we're going to say, okay, where is 3x cubed minus 9x squared less than 0? Okay, and of course you're going to have to solve this as an inequality. So we're just going to pull out 3x squared. We're going to have something very similar to question 1, and then I'm going to have x minus 3. And this is going to be, where is it less than 0? Now from here, of course, I've got to get my critical values. And I know my critical values are at 0 and at 3. So then I'm going to draw my number line, like so. Okay, I'm going to put down 0, and I'm going to put down 3. And all I'm going to do is I'm just going to start to plug in values here and see what I get. So let's take a value less than 0, because remember this is going all the way to negative infinity, and that is going all the way to positive infinity. Okay, if I take minus 1, so minus 1 squared is going to be 1 times 3 is 3, which is a positive. And then minus 1 minus 3 is a negative, and a negative times a positive gives me a negative. All right. And then let's take a number between 0 and 3. So let's take 1. So 1 squared is 1 times 3 is 3, which is a positive, and then 1 minus 3 is a negative, and a positive times a negative gives me a negative. And then if I take anything past 3, so let's take 4. So 4 squared is 16 times 3 is 48. That's a positive times a positive, and a positive times a positive gives me a positive. So in this case, you can see that my solution, where is it less than 0? It's everything less than 3, excluding 3, because at 3, I will get 0. So in that case, my answer is then x must be less than 3. And that is my answer for 9.4. And this, well, we managed to do this question in about 10 minutes. And I hope this has been of benefit to you when you see it, whenever you see it. And of course, I'm going to leave you with that. The sessions will get longer as we start to get more people coming into the sessions. But for now, we're just going to keep it short and sweet. And see you next week, I hope. Thank you.